Hello and welcome to today's 2021 MEF 3.0 Proof of Concept Live Showcase, where MEF members collaborate to demonstrate MEF 3.0 based use cases that validate, evolve, and even inspire the work of MEF. I'm Kevin Vachon, your host, and today we're showcasing POC 131 entitled Orchestrated Multi-Edge Clouds with NTT Communications, Netcracker, Juniper, Microsoft, and ADVA. What we're going to see today in this POC is how enterprises can benefit from multi-edge clouds using open edge compute platforms with a single window user experience. We're going to kick off today with an introduction to the POC by Wenyu Shen, Senior Engineering Manager at NTT Communications. We'll be followed by the demo itself, a business-focused panel, and then we'll have a Q&A session. And a reminder that at any time throughout the event today, you can queue up your questions by selecting the Q&A tab on the right of your screen. So with that, let's get started.
Hello everybody, my name is Wenyu Shen with NTT Communications. It's really my honor to kick off this MEF POC showcase, and I would like to start with an executive introduction, give you a quick POC review, which is all about orchestrating multiple edge clouds. Before we go further, I would like to give you some background and motivation behind this activity. As shown in the left picture, single data center and single WAN was the standard topology for the enterprise IT system, while with the rapid evaluation of the cloud and WAN technologies, we have seen a paradigm shift towards hybrid IT in which hybrid cloud, hybrid WAN have been penetrating into the enterprise IT system. This picture shows a typical deployment model for realizing hybrid IT, which is being offered in production by many CSPs, including us. First of all, an SD-WAN gateway can be deployed on a CSP-provided VNF platform. This SD-WAN gateway is mainly designed to terminate the regional traffic and further send them to the traffic cloud such as AWS, Azure, and public cloud exchange service. At the same time, an end user can also deploy other VNFs on the same platform, such as a proxy to terminate the remote access, or a UTM to provide a regional internet gateway, or even to provide other value-added service such as WAN optimization. However, we have seen some new changes in customer needs when they move toward digital transformation. So far, network-related functions such as SD-WAN, firewall have been mainly requested, but now users are asking for more and more upper-layer functions such as AI, IoT, gaming, self-driving, remote control, and etc. Moreover, in order to pursue low latency, reduce WAN cost, and guarantee privacy, there is an increase in the need to migrate the system from the cloud to the edge and even on-premise. In order to keep up the pace of the digital transformation, edge computing together with the 5G has become the main focus in most of the CSPs' investment, including NTT Communications. In our edge computing blueprint, multi-stage edges are under planning, which will be built at distributed location across core, access network, and to even on-premise. We are aiming at launching a new fixed mobile converged service oriented mainly for enterprise user by relying on this multi-stage edge platform, on which functions for wireline service such as SD-WAN VCP will deploy together with the function for wireless service such as UPF and vRAN. Moreover, other value-added services such as AI, IoT, CDM, MEC will be deployed on the same platform as well. Select your own service, deploy it to the right place, connect them end-to-end with the guarantee networks. This platform will pave the way for customers to move towards their digital transformation. While there are still many challenges ahead, first of all, we are still seeking for a marketplace in which an end user can pick up an application and deploy it on demand, and a single pane of glass for managing the distributed computing resources. Since the edge will be expected at distributed location, we foresee a solid requirement for more flexible networks, to connect these edges on demand, starting from LAN to WAN, and finally the cloud exchange. Last but not least, only with the collaboration between CSPs and OTTs could make the edge dream become true. So we are investigating resource and revenue sharing model among partners. Some ideas are shown here, such as to deploy OTT's application on CSP's edge, to deploy CSP's services on OTT's edge cloud, and CSPs to collaborate with OTT to manage the services of the OTT's edge solution. This proof of concept demonstrates how CSPs can accelerate adoption of multi-edge cloud services through the orchestration of applications and the connectivity on open edge computing platform. Enterprise-oriented services are purchased from a digital marketplace and automatically deployed across multiple edge platforms, such as on-premise, network edge, and public cloud. Moreover, by orchestrating the edge with the existing underlay and overlay network service, including Wi-Fi, WAN, SD-WAN, and cloud exchange, the POC also shows an end-to-end story seamlessly connecting the on-premise environment to the centralized cloud. One highlight of the POC is that it shows the possibility that the CSPs and OTTs can work together to create a stronger edge platform than whatever we have seen so far. In this POC, Netcracker brings their digital marketplace, end-to-end service orchestration, and edge orchestration. Juniper provides their Wi-Fi, secure SD-WAN, and network assurance solution. Advar Ensemble works great as on-premise edge, and Microsoft offers their Azure IoT Edge and Azure Stack. And finally, NTT Communications bring flexible interconnect, network edge, and an open source 5G solution. I believe that you cannot wait to know more about the details of the POC, so let's jump into the demo scenario now. Welcome to the MEF 3.0 POC technical demo, Orchestrated Multi-Edge Clouds. In this POC, we would like to demonstrate two customer cases relying on edge computing technology. First of all, we assume that the customer wants to open a new warehouse branch with AI-driven smart sensors and a face recognition system. We will show how a DAS-based IoT service with SLAs enables the customer to reduce the opening time by utilizing CSP-provided applications and transport infrastructure. Next, we will move on to a migration scenario in which we focus on a manufacturing branch whose IT division foresees a new requirement for a network with higher capacity and lower latency for its production line. We will demonstrate how moving IoT applications to the on-premise edge allows the customer to overcome the network bottleneck and quickly improve production performance. We will start with the warehouse branch opening from scratch. The on-premise edge will be provided on demand with SD-WAN, network probe, and the IoT application, while a security SD-WAN gateway will be deployed on the CSP's edge cloud. We will also show the provisioning of an end-to-end service to connect this newly built branch to a cloud-based path. Next, we will demonstrate an upgrade process of the manufacturing branch from LTE to 5G for higher capacity and low latency. Here, by utilizing SD-WAN, we will also present the possibility of implementing the network slicing. Another highlight is that we will introduce the OTT's edge to load the SD-WAN gateway and connect it to the Cloud Interconnect service. In both scenarios, we will show the zero-touch provisioning, the end-to-end orchestration and assurance, and live traffic running from the sensors towards the cloud.
Let's now jump to our first scenario for end-to-end IoT service provisioned across LAN and Wi-Fi equipment, local and public clouds, with end-to-end service tests and live sensor traffic running through this entire network. We start with the digital marketplace, where we have three offers configured for this POC. The first two are for scenario number 1, and the third one is for scenario number 2. We begin by ordering on-premise cloud appliance capable of hosting different workload types, such as applications, VNFs, and CNFs. We proceed through the checkout process by specifying equipment quantity, address where the appliance needs to be delivered, and once we submit the order, the equipment is shipped to the site. Underlay connectivity service was provisioned in advance.
When the box is received on-site, just provide the power and connect it to the internet. Just that, and the magic will happen.
Now we are ready to start ordering our end-to-end IoT service over LAN. We select our second IoT video surveillance bundle for LAN, consisting of IoT application, quantity of workload, LAN equipment bundle, WAN-side connectivity option, cloud option, and direct public private cloud interconnect. This small toggle on top instructs service and edge orchestrators to intelligently decide where to put the application among available cloud locations. This decision can be made by orchestrators themselves based on configured application descriptors and several parameters, or in conjunction with analytics module, which takes many other conditions into assumption, such as application type, cloud location capacity, available site bandwidth, and other things. Now we submit the order to service orchestration. Service orchestration accepts the order from the marketplace via LSO Legato interface. It has entire IoT service models in the service catalog. It is centered around IoT applications with various cloud options and connectivity options attached to it in the form of RFS nodes. There are multiple parameters in this model, and some of them are exposed for manual user input, while others are either automatically calculated or fetched from external systems. So in this case, we manually specify SSID name for the wireless LAN, we leave VLAN number blank, we specify pre-shared keys for the wireless LAN access, specify connection name for the flexible interconnection service by entity, and also we specify the pre-shared key for the IoT application itself. After we specified necessary parameters, service orchestration automatically composes the workflow based on the inputs, various rules configured in the service specification, and systems that require to be provisioned as part of the order. It composes the workflow and defines the tasks and order of these tasks to be executed to have the entire service provisioned. In our case, there are several workflow streams running in parallel, such as on-premise cloud provisioning, IoT central application instantiation, and entity flexible interconnection service deployment. In Adva Ensemble Orchestrator, we can see a network service up and running. It has 3 VNFs, Juniper VSRX for SD-WAN function, Microsoft Azure IoT Edge module for video analytics, and NetRounds IP probe for network testing. VNFs are now ready for further service configuration. Service orchestration now configures Juniper VSRX for on-premise cloud applications connectivity. Once Juniper VSRX VNF is up, it goes through zero-touch provisioning process with the CSO, with configuration pushed to it by the orchestration. SD-WAN service will be reviewed in details in scenario number 2, so I don't stop on it now.
MIST site configuration holds the RF templates which define basic RF and MIST AI-driven radio resource management parameters. Here will be the list of access points in your site. Here will be the list of switches and information like missing VLANs learned by MIST. To add security for the IoT wireless LAN, we completely segment each group of IoT devices using multiple passcodes. If an IoT website has a security breach, it won't affect the other devices. The installing technician can use our mobile app to claim an AP or switch via QR or claim code, or Netcracker Orchestration can do this automatically using the claim code for all devices.
When missed APs and switches are received on-site, just provide a power and connect it to the on-prem edge. Then, all the devices will be automatically registered with MIST portal and discovered by the orchestration system.
At this point, the switches and APs are configured and running. MIST shows the topology of the switches and their connected wired and wireless clients. Insights gives a detailed overview of the network experience for the entire site, including the switches, APs, wired, and wireless clients.
This is our flexible interconnect portal. An end user can easily establish the connectivity to multiple public clouds on demand, including AWS, Azure, GCP, and Oracle by few clicks. We also introduced a latest service called Microsoft Azure Peering Service to make our FIC directly connect to the Microsoft backbone. This public peering helps us provide better user experience and stability for PaaS and SaaS, such as O365 and IoT Central. It's also possible to modify the bandwidth on demand by few clicks. As you see, from 10 meg to 1 gig, very easy, isn't it?
We've got our IoT Central application up and running and configured for video analytics use case by using YOLO Video Analytics Each Device Gateway. This gateway has several modules predefined in the device application template, and these modules will be pushed to the IoT Edge application on the on-premise cloud once it was provisioned and configured by the orchestration. In parallel, orchestration takes from IoT Central application parameters necessary for IoT Edge module configuration and pushes it there. This includes scope ID, registration ID, and symmetric key for authentication. We can see that IoT Edge virtual machine is now configured, and there are YOLO Gateway modules downloaded here and are running fine. In YOLO on IoT Central app, we can observe each module registered successfully. We can see operating system version, available memory, but currently there are no cameras registered. Now we'll add the camera and put our branch under control with video analytics. We define object detection to be face and person recognition. After some time, we can see there are events registered by the system and can view video streams stored that generated this event, and actually, the system recognized the face. The final step for our IoT service instantiation is end-to-end SLA test by Paragon Active Assurance Software Agent, formerly known as NetRounds. Service orchestration triggers test execution via API and supplies IoT app URL and IP addresses to be tested by NetRounds. After successful test, we can observe end-to-end service graph in the orchestration portal and can view various service parameters such as SD-WAN VNF configuration, its IP address, and other things. We can navigate to Service Test tab and download Service Birth Certificate to be shared with the customer, which confirms initial service SLA compliance. If something goes wrong and we start getting alarms, for example from mist, we immediately see it and can navigate to system for detailed troubleshooting.
After the network was up and working, we saw that one of the APs was intermittently going offline. We see in the Mist wireless monitor view that the AP uptime is not meeting service level expectations. Marvis, our AI assistant, will tell us what's wrong with the network. Before I even ask, Marvis tells us that we have pending Marvis actions. Marvis actions tells us the steps to remediate the issue, which is the precursor to the self-driving network. Not surprising, Marvis tells us that the AP is offline and recommends what to check. But what's groundbreaking is that it told us that we have a bad cable between the AP and switch. Once the cable was replaced, the demo was back up and working smoothly.
In our second scenario, we perform upgrade of LTE network with 5G IoT slices stitched with SD-WAN network in multi-cloud environment. This is our initial service graph running LTE VPC VNF. We will replace it with 5G core, deploy a couple more IoT apps, and cover them with IoT slices across SD-WAN network. We order 5G bundle number 3 from the marketplace containing G-Node B, 5G core VNF, SD-WAN, and IoT apps options. We select existing site as location for the service and specify slices to be added here. Also, we include a new network edge cloud for our location as suggested by the system to comply with service SLAs. We double-check added positions and place the order. Orchestration accepts the order and dynamically composes workflow to upgrade the service, add necessary applications, and perform service provisioning. In Adva, we can see connector for our VNFs configured with the necessary for 5G core parameters and VNFs instantiated within the new network service. In Juniper SD-WAN system, we can see our 5G branch up and running now. It has its WAN side provisioned and LAN side stitched with other VNFs as defined by Advanced Network Service. Netcracker Service Orchestration pushed here firewall and SD-WAN policies for the two IoT slices. In the firewall policy, we've got our IoT traffic sources defined. This comes here from the orchestration, which is aware of 5G network configuration. Firewall rules allow communication for these sources only with IoT central application and prohibit the rest. Breakout profile excludes these addresses, making them reach to the Azure only via internal network NFIG. SD-WAN policy defines how our IoT applications traffic should be handled from QoS perspective. It specifies that for traffic originating on our side, predefined steering profile will be used, which contain SLAs and WAN link failover properties.
As shown in the Azure portal, both VM and IoT Edge service are running now. Let's first look at the VM service. We can see VXRX is running well, and we can also check the VM details by just a few clicks. Next, let's take a look at IoT Edge service. Here, we can see all the necessary containers for the AI inference are deployed and in running status.
We've got our second Microsoft Azure IoT Central application instantiated. It will be used for environmental sensors tracking. IoT Edge module for it is provisioned in the Network Edge Cloud this time. On-prem Edge Cloud is used for another video surveillance IoT Edge module. Traffic for this application will utilize SD-WAN and firewall policies configured in Juniper CSO. We specify parameters to be monitored here, which is temperature and pressure. After that, we can see data coming to the dashboard from our branch. NetRounds probe is actively tracking application performance so that we can see in real time how our end-to-end network performs. This concludes our second scenario. We successfully upgraded our branch with 5G network and IoT slices, instantiated and configured several applications in cloud locations, including Azure Stack Edge, and configured them for operation. We also configured SD-WAN network to maintain SLAs for our apps. This is it for today. Thank you very much for watching, and we hope that it was informative for you.
So hello everybody, and welcome to our business roundtable. I'm Sue White from Netcracker, and in this session we're going to talk a bit more about the business value that proof of concept brings to both service providers and the enterprise customers. So I'm joined here by representatives from the team, so perhaps if you'll introduce yourselves briefly.
Hi, my name is Fumina Tan. I am a solution architect with NTT Communications, responsible for edge computing platform development.
Hi, I'm David Nograbau, Service Provider Marketing Director for Strategic Alliances at Juniper Networks.
Hello, my name is Michael Hefner. I'm Vice President of Product Management for ADVA's Edge Cloud Business Unit.
Hi, I'm Maura Hammeroff, Director of Product Marketing for Azure with Microsoft.
Hello everyone, my name is Yaroslav Krasnov. I'm a product manager responsible for cloud as a solution with Netcracker.
So now the expansion into vertical industries for service providers has been a really, it's a strategic initiative. And of course, we're going to be using cloud and 5G as the core components to make this happen. So I'd like Fumina from NTT to explain a little bit more about how proof of concept really helps with this goal.
Well, in this talk, we are working on the feasibilities of 3 new aspects, which we believe will be important for communication service providers to build a viable business using Edge Cloud. The first one is offering multiple edge options. We know some applications such as smart factory, smart city, smart mobility require low latency, privacy, WAN cost reducing, and autonomy. With rapid evaluation of cloud and WAN technologies, these applications are relying on edge computing is increasing. By combining services of multi-edge clouds, we offer customer more options, either network edge or on-premise, with much lower cost. This benefit is you can make the choice freely. And the second one is combining connectivity with services. We use flexible network to connect each single edge. These flexible networks are like using Wi-Fi and 5G network to connect IoT sensor and on-prem edge, using SD-WAN to connect on-prem edge and network edge, using Cloud Exchange to connect public cloud. In this POC, we achieved not only end-to-end provisioning, but also end-to-end monitoring and assurance. Flexible network is also the fundamental of hybrid ICT. And last but not least, accelerating the collaboration between CSPs and OTTs. In this POC, we have challenged OTT apps on CSP edge, CSP network functions on OTT edge, integration between CSP and OTT, and orchestration for combining these two. Successfully confirmed the possibility of the mutual collaboration. We believe all these three need to come together to drive new business from verticals and take all the complexities away from enterprise doing it themselves.
Thanks, Femina. So let's expand on some of these points a bit more, and perhaps we can start with connectivity, because one of the things we're doing in this proof of concept is end-to-end connectivity, not just the WAN, but to the LAN as well. And obviously we're covering private 5G and we're covering Wi-Fi environments as well. So perhaps David from Juniper, you can explain, a bit more about this end-to-end connectivity. Is this something new? Was it not possible before?
Well, for the MEF POC connectivity, Juniper provides the enterprise branch networking through Wi-Fi and LAN, while the external connectivity is provided through SD-WAN. Both Wi-Fi and SD-WAN can't be considered new technologies. However, we're bringing a new approach here, end-to-end connectivity, integrating Wi-Fi, LAN, WAN domains with the help of AI. Juniper Mist delivers scale and agility through a modern microservices cloud architecture, and it offers groundbreaking services, assurance for Wi-Fi, wired, and WAN, location services, premium analytics, among others. Mist also has an inline AI engine for unprecedented insight and automation that simplifies the full life cycle of the enterprise branch deployments. An IoT environment like this POC, where applications can dynamically sit on-prem or at the edge or in the public cloud, it needs a network that can rapidly adapt to match the application requirements. The Juniper SD-WAN VNF that runs on the edge cloud on-prem and also provides security to the enterprise environment. The access technologies for this POC are Wi-Fi 6 and private 5G, and both make use of the SD-WAN to connect externally. For each application, SD-WAN finds the best route, internet or MPLS, to get to basically the entity's flexible interconnect cloud fabric that brings the traffic to the public clouds through the entity's private network. All that integrated in the end-to-end orchestrator that simplifies the rollout of this type of setups.
Hey, thanks, David. So let's talk a bit more about the cloud platforms themselves. Obviously, in this proof of concept, we're showing different types of edge platforms. We have those on-premise, we have the different parts of the edge network that we're simulating. So Mike from Adver, perhaps you can explain a little bit the difference between the premise edge and the network edge, and why you need both really to address different vertical industries.
Sure, thanks. So from the Adva perspective, the difference between premises-based and service provider edge cloud is primarily a matter of performance and scale. In both instances, shared compute infrastructure can support a variety of workloads, as David mentioned, whether it be managed networking services that could be offered by the CSP or private workloads that are managed by the end customer. Customer edge is typically defined by smaller deployments. We see single node or small cluster platforms, as well as lower overall bandwidth and usually much more stringent latency requirements. And due to the highly distributed nature of those deployments, customer edge use cases require a high degree of automation and remote management capabilities. While at the service provider edge, we're dealing with the first point of service aggregation, which generally requires more computing resources, higher data processing capacities, and things of that nature. But both models should provide an open framework on which virtualized or containerized services can be instantiated, service chained, and then eventually monitored throughout the service lifecycle. So with this level of flexibility, edge cloud platforms are really ideal to support the unique and changing needs of different industry verticals. And at ADVA, we're currently deploying edge solutions with a number of industry verticals, including smart cities, banking, oil, gas, energy, railroads, things like that. And while most of these solutions require some form of managed networking services like SD-WAN or routing or wireless connectivity, the other applications are generally unique to the specific customer use case. And we've seen things like, again, advanced security, IoT sensor data collection, processing, data, video processing and analytics, as well as, again, private enterprise IT workloads.
Okay, thanks, Mike. So let's stay on the topic of cloud platforms and talk about public cloud, because obviously public cloud is now a core part of the service provider's strategy. But how applicable is the public cloud to the edge and to the premise? And of course, Maura, this question is for you, Microsoft.
Yeah. Well, so I think building on what Mike said, it's not an or, it's an and. We really believe that intelligent edge with the power of the intelligent cloud will transform the way we interact with the digital transformation and further blend physical and digital worlds for real innovation. At the high level, the opportunity is to bring together those two worlds, the digital and physical world, to create limitless connections, bring the power of AI and ML to react real time with events and delivering really the compute across that spectrum. That's a huge part of our vision. That's how we design Azure, and it's not new to us. Like this hybrid approach is something that we see across all of the businesses that we support. We meet customers where they are. They're looking to deploy all kinds of workloads at the edge, and we expect that with OSS and BSS orchestration, it will be the same.
Okay, great. Thanks, Maura. So now let's take the discussion back up to services. We've talked about the end-to-end connectivity. We talked about the different edge platforms, but of course it's the services that we really want to get to, the new digital services. And going beyond connectivity to add new value-added services is obviously something we've been striving for as an industry for some time, making a little bit of progress. But I'd like to ask Jaroslav from Netcracker to explain, our perspective on, do we have the piece parts ready now to really make this happen? So Jaroslav.
Yeah, indeed, value-added services have been an important topic for a very long time. But actually, and all this time it was viewed just as an add-on for the primary B2B connectivity service with, for example, security or recent SD-WAN on top. So in this POC, we are demonstrating how CSPs can change their business model to become VAS-centered. So this can be achieved by crossing the connectivity border and offering more digital services inside enterprise focused around business-critical applications. And I should admit that currently there are necessary commercial solutions and products in the market to make it happen with high level of automation. So, for example, SD-WAN gives unified transport, SD-LAN and SD-Wi-Fi, already mentioned before, so they allow to dive deeper inside the enterprise markets and allow simplified management of enterprise networks with the fancy AI features. So cloud allows to forget about entire IT infrastructure and 5G and Mac, just bring workloads together closer to the end users, focused again around applications with a network slicing. So in this POC, first of all, we did a feasibility study of how complex it is to build these kinds of solutions and to validate the overall technology readiness. So we found out that different pieces are at different levels of evolution, which was kind of expected. But the biggest outcome is that for service providers to move forward, it will be just impossible without bringing ecosystem-based automation platforms that help them to stitch together different pieces of technologies. And actually the work that MEF is doing today by standardizing SD-WAN, security, and clouds is the right way forward, I believe.
Okay, thanks, Jaroslav. And, of course, we gave an example in the proof of concept we saw earlier of, the factory automation and an IoT type of MEC application. Perhaps it'd be good if Firmina, you can discuss some business outcomes from, other industries where, the same concepts of the POC can add value to.
Sure, I have a story about airport security control system. They are considering implementing a cloud-based face recognition technology. Turns out, a huge amount of data to process and the network latency can slow down the checking process, cause costly inefficiencies. Moving the face recognition software to an on-prem edge cloud will improve the overall process, enhance the system privacy by keeping the data local, and remove dependencies away on the run. The learnings of this MEF talk provides a blueprint on how service providers can orchestrate end-to-end multi-cloud environments to run time-sensitive applications and controlling the delivery of the end-to-end user experience, including on-prem wireless, wired, and WAN connectivity.
Okay, great. Thanks, Femina. Now we're talking about obviously managed services here, service providers offering, not just these new digital services to vertical industries with the connectivity, but also, obviously managed in a managed or hosted way. So what's really important here is the topic of security. So perhaps, Maura, you can explain a little bit more about the security strategy that was implemented by the team.
Yeah, of course. So first, our cloud model is based on the concept of zero trust to establish the services and connectivity. And by adding the right cloud and the right model, you can argue you're more secure. At Microsoft, we invest over $1 billion in security R&D. We have over 3,500 cybersecurity experts, and we analyze more than 8 trillion signals daily. And you get that with your services. So when we talk about security, we have and we recommend that you have a holistic security approach to secure across the cloud, your multiple edges, and your application. And I'll just give you some examples of some of the solutions that you can apply across that. Azure Security Center, for example, it helps provide unified security management and advanced threat protection for the systems running both in the cloud and in the edge. You have that monitoring across. And another example is single identity managed. So you have that one point of control, and you can really truly apply the zero trust concept to everybody accessing all the way from your devices to the most sensitive aspects of your network, then again, across cloud, network edge, and on-prem edge.
Okay, thanks, Maura. So that takes us to our last topic. Now, since we are offering services, multiple technology domains, multiple service providers, what's obviously very important here as well is how a service provider can actually maintain those business SLAs to its enterprise customers. So the whole topic of assurance becomes absolutely critical. So David, can you explain a bit more about how we achieve this?
Well, sure. So to achieve the desired experience for each application, enterprises require strict SLAs on the end-to-end service. So the goal is to minimize the impact of any network failure that should be located, fixed rapidly. Imagine having to interrupt an airplane boarding due to a network failure, back to Femina's example before. At the wireless, wired, and WAN level domain, basically AI-driven assurance with machine learning is a must to be able to anticipate and react to any network issue. To satisfy the application level SLA, it's also important to constantly monitor the network quality end-to-end from client to cloud to be able to react rapidly. Juniper Paragon Active Assurance, or formerly known as NetRounds, will provide the activation testing, end-to-end quality monitoring, and remote troubleshooting for the full service life cycle to not just keep the applications up and running, but also provide a great application experience.
That's great. Thanks, David. So thanks, everybody. And I'll hand back to Kevin, where we'll actually take some of the further Q&A from the audience. Thank you.
Thanks, Susan, and thanks to the panelists. Great panel. So now I'm going to be joined by Daniel Barlev, who is MEF's VP of Strategic Programs. He's also the architect and director of our MEF 3.0 Proof of Concept program. He's going to moderate the Q&A today. So Daniel, take it away.
Thank you, Kevin. And I'd like to invite my panelists for the Q&A session to join me on screen. While they're doing that, we've received quite a few questions already, but if you would like to add questions, you have a tab, Q&A tab, so please feel free to add them now. So we'll kick off with questions to our team from NTT and Netcracker, Adva, Juniper, and Microsoft.
The first question is for Wenyu. Wenyu, is this ready for production, this solution that's been demonstrated? Is NTT ready to actually offer these types of services yet? And if not, what needs to be done in order to achieve that?
Thank you. My name is Wenyu from NTT Com, and thank you for the great question. And I think, to be frankly, this is not for production yet, but I think it's very close to the production for now. I think when we're talking about the edge computing, people tend to focus only on the computing infrastructure, such as the edge data center, such as Kubernetes platforms, etc. But actually, we did the same thing in the beginning when we think about production and also for the park. But we begin to notice that the computing infrastructure is only one piece of the whole story. So one important fact that we ignore was the connection between this computing infrastructure, which includes the access networks such as 5G radio, Wi-Fi 6, WAN networks, and cloud fabric. And moreover, all of these pieces just work together in order to provide the service. So we began to be aware of the importance of the need for an end-to-end provisioning and the end-to-end monitoring and assurances as well. I think the big milestone for this park is that we successfully show the capability of a fully managed edge computing service that spans from sensor device until the cloud service. I think that will be a great milestone for us to start the journey of the production. Thank you.
Hello, this is Tom Dixon. Daniel just lost power in his neighborhood, and we're getting him set up to take over.
So maybe while we're waiting for Daniel, we can just have another question that I could see came in. Maybe one for Mike from Alpha. What's the biggest challenge of deploying edge compute? Since we're talking about the edge platforms, can you maybe address a bit on that?
Yeah, sure. So Mike Hefner from ADVA. So I think as we heard in the business panel and certainly saw in the demo, there's a lot of different use cases that can be enabled with these kinds of edge computing solutions. At its core, from certainly the way that we're doing as well, a lot of these solutions are meant to be composed of a suite of open platform components that offer a very wide array of best of breed ecosystem, or coming from a wide array of best of ecosystem providers, best of breed, sorry. And on the one hand, from a business perspective, that makes sense for service providers who want to maximize their revenue opportunities with a lot of different use cases, and also with a competitive vendor ecosystem that helps them keep their costs down. But from a product and technology perspective, I think one of the things that we've seen is coordinating across a large set of ecosystem providers can be quite challenging. If you throw into the mix all of these different open source and standardization efforts that are all dabbling in the edge compute space, the path from service concept to service deployment can be long and potentially painful. So it's kind of with that background that for us, it's been pretty easy to see the importance of driving these sorts of proactive integration activities that allow the vendor community to work through as many of these issues in advance of specific customer projects. And that's why, what MEF is doing with these proofs of concept is so important, and why we've been, really happy to be able to participate, because it's given us a chance to collaborate with a large number of ecosystem partners, service providers, test out interesting use cases, and work through some of these integration challenges in advance.
Okay, great. Thanks, Mike. So I think we're still missing Danielle, who's power.
Yeah, so he's having issues with power. I can do some of the questions.
Yeah, that would be great. Thanks, Tom.
So one of the questions we have here is, what are the roles of CSPs and OTTs in the edge computing industry? Wenyu, would you want to take that?
Sure. Thank you, Tom. I believe that the main role of CSPs and OTTs should be the same, to provide edge computing platform, which should include not only the end-to-end computing resources, but also the network infrastructure. But however, one of the challenges that we're facing with is that the edge computing technology should have a huge initial investment scale. That's why in the executive introduction, I mentioned the importance of the partnership among the service providers and the OTTs. This collaboration is expected between CSPs and CSPs, but moreover, it could be between CSPs and OTTs. In this proof of concept, I think we successfully showed the possibility, of network collaboration model. We deploy Microsoft Azure IoT Edge on CSP's Edge and deploy CSP's SD-WAN service on Azure Stack. At the same time, we deployed the latest network service called Microsoft Azure Peering Service to show the interconnection between CSP's networks and OTT's network. Last but not least, we also showed the possibility of orchestrating different edge solutions coming from either OTT and CSP's domain. So that's my point of view. Thank you.
Could you explain how the CSP can evolve this solution with more services over time? How does this edge compute architecture extend to support other use cases and other industry verticals?
The communication service provider will exactly planning to implement this solution into commercial services step by step. At the first, we will start with on-prem edge that close to the customer mostly, and make it more intelligent by enabling the IoT Mac devices or cameras connectivity instead of just doing routing or security as it used to. And after the customer edge, we will enable edge computing such as data analysis or AI process on network edges to distribute the computational load in the cloud side and mitigating delays in sensitive areas. These network edges means not only base stations or data centers the CSP already have, but also street light or traffic signal or anywhere need to be developed. And for sure, multi-tenancy will be supported at network edges. Our final goal is an automated and seamless AI-driven end-to-end cloud service. With this POC as a starting point, we have begun to work on commercialization and collaboration with related partner OTTs. Thank you.
Thank you. How does end-to-end service troubleshooting work in an architecture composed with so many domains? And to draw on that, was the situation with everyone working from home, did that complicate things? Did that make it easier? Perhaps someone from Juniper would take a chance at this?
Yeah, no, that's good. I think that the fact we used the software, and Nancy knows it very well, so helped a lot on this remote support for the POC. But I think enterprises running critical applications in the real life, and I'm not talking now just specifically about the experience in the lab, but it's when they run those critical applications in the cloud, they'll be looking to buy a managed service with the client-to-cloud experience. And basically, this needs to satisfy their needs for the critical applications. Not only its domain needs to work standalone, but also needs to work end-to-end. So if Wi-Fi is on or SD-WAN is on, but the application doesn't communicate, this is not good. Basically, then we take two approaches here. So first, at the local domain, where many things can go wrong, right? And here's where we are bringing the AI-driven operations for service assurance. And this is driven by Juniper Mist in the demo, where basically we are continuously monitoring the health of Wi-Fi, LAN, SD-WAN. In case of degradation of the service, it will be able to identify it quickly, whether it's an access point problem or it's a misconfigured VLAN or it's a WAN problem, and it will fix it, even if it's a bad cable, as Nancy shown in the demo before. But the second important thing is now end-to-end, as I said. So every domain may work correctly, but we need to build the service end-to-end and satisfy it. So it's known that over 60% of the network problems are discovered first by the end user. We need to revert that. And here's where Juniper Paragon Active Assurance, which is formerly known as NetRounds, provides its magic. So basically, once the service is provisioned, it can confirm that the configuration works correctly for the application with real-time traffic, and then it is delivered. But once it's delivered, it's continuously monitoring it as well, all the time, real time, so it can detect as it goes wrong before it's too late. So that would be the way we are assuring it end-to-end.
Thank you. I have another combined question here. So would someone be able to comment on how MEF standards guided the design of today's POC, and also potentially what was learned during creation of the POC that could be used to formulate the standards as MEF work moves forward?
So MEF LSO did a great job by guiding providing us with a framework of how to model the service, how to order the service from marketplace, and how to provision it to SD-WAN system, for example. Right. So the job that was done by MEF really helped us here. But of course, looking at the POC results, I can see a lot of work to be done in future. So one of the things that MEF LSO does not cover for today is these multi-edge workload placements. This is where we see the ongoing work to be done. Another thing is that currently, I believe there are no standards that dictate how to do multi-tenancy across CSPs environments. And this is another topic where MEF can help us and provide some framework how this can be implemented.
Thank you. Is there anybody else who has insight into that?
I was just going to say, this is Mike again from ADVA. I'll just jump in and maybe even tie that back to one of the earlier use cases or questions around, kind of how can this type of technology extend to support other use cases or other industry verticals? And that was, some of what I was pointing out in my first response, which was, having these platforms built around, open source technology, open standard interfaces, all of these solutions are inherently multi-vendor. There's very few companies out there that can deliver a full one of these things end to end, as demonstrated in the proof of concept that we showed. And so, having these types of well-defined interfaces that MEF is working on really, helps streamline, the ability to bring in and onboard other partners to go into different use cases or other industry verticals where 80 or 90% of the core capabilities may be the same, but they all have their unique twists and requirements. And so, again, having those, open standard interfaces has really been a massive help in terms of, supporting this multi-vendor interoperability.
What would you say that would be the minimal set of functions that need to reside in the on-premise edge?
I can start answering that. This is Maura Hamra from Microsoft. I think it depends a lot on the type of application. You have to look at the components that really need that ultra latency compute, like, for example, highly localized processing or resilient solutions. Some examples of that are capabilities like around industrial automation, intelligent video processing, mixed reality. So you have to look across, like, what is it you're trying to accomplish, and what needs to be at the edge, and what can be elsewhere, like, for example, storage or a large set of data. So it really varies, and I think that's one of the beauty of the work that we do across the different components, the different partners to provide this to customers, because we each bring some piece, the cloud, the connectivity, and what you're really doing and you're really accomplish at the edge.
Mm-hmm. Yeah, and if I could jump in just from our perspective as well, from a customer premises perspective, and I think just kind of elaborating on what Maura said, it's a lot of kind of reusable kind of componentized services, so to speak. So, as a platform vendor, we're not actually building any top level applications. What we're really providing is an infrastructure, cloud management resources so that we can be remotely managed by third-party management platforms such as Netcracker, the ability to plug into various underlay networks, whether it be, mobile or private IP or public internet, provide that management connectivity so that the applications running on top of us can then build the overlay connectivity and deliver some of those applications. Those end customer applications, but also, manageability, the ability to automate those, the deployment and day-in management of those end platforms is an important service. Also, just providing a toolkit, to, again, depending on the types of use cases, as Maura said, there's going to be different requirements for latency and throughput, and so having the ability to do dynamic resource offloading of certain traffic flows to hardware accelerators or whatnot. Again, those are all kind of, component services that a platform can provide to a northbound management system to essentially turn on and off depending on the use case. And so, those are some of the things that, that we focus on as well as a platform provider.
Well, that's all the time today we have for Q&A. I'd like to thank our panelists, and we'll be going back to Kevin for wrap-up. And I think it's pretty clear that not only do we need edge compute, but we also need edge power.
Yeah, Tom, to build on that, firstly, let me thank Susan and Tom for their manual but very, very fast failover for the Q&A host. And Tom, you mentioned that. I was thinking more around an SD home solution with integrated UPS with 4, LTE or 5G backup, something like that. Clearly, we need to step up here in the world we live in. But look, very, very impressive talk. There's so many different discussion points that's tough to summarize. I took a few notes here. Very forward-looking, of course. So many potential forward-looking use cases beyond what we saw today. Some things that stuck out to me is the integration of cloud services and connectivity. And as many of you have been around for MEF for a while, when we started looking at orchestration a number of years ago, we really focused on connectivity services. But we knew that the ecosystem would extend to the enterprise, to machines and people at that end, through to cloud-based services wherever they ultimately become located. And so many components, and as we heard from best-of-breed sources now being pulled together with this end-to-end orchestration solution. All pulled together in a managed service. And I think at the end, Yaroslav and Michael really talked about the impact of the MEF standards, not only where we are today, but where we can go. We're looking at being able to orchestrate services at the MEC using MEF APIs, and I would encourage you to engage with MEF CTO Pascal Menezes, who's driving this, and really leverage the work we've done with our open APIs beyond the initial services that MEF contemplated. So great job, people. As we close out today, let me tell you about the MEF 3.0 Proof of Concepts Awards. Each POC is eligible, and there are 4 categories: innovation, business impact, market game changer, and judge's choice. And they're going to be judged by a panel of 8 independent analysts. To continue the conversation today, you have a couple of options. There's a link on a slide that you're going to see, and you'll be able to put that link in your browser. That's a Zoom link, and you can actually join the team today and have Q&A with them. There's also some contacts on the slide, and if you want to reach out to them directly for some follow-on. Now, for more information, you can go to mef.net/POC/131, or you can just Google MEF POC 131. Takes you to a page that has an overview of the POC, network diagrams, supporting materials, blogs, etc. And also the POC will be available on demand on that page. So if you like what you saw, have your colleagues go and see the POC on demand at your convenience. So with all of that, I'd like to say thank you for everybody that had something to do with pulling this together, the POC team itself, the MEF production team, and of course, you for attending today. And we'll see you on the next MEF 3.0 Live POC Showcase. Thank you.